Welcome back to our Chem 152 video series. In this video, we'll be going over how to calculate concentration units. In this question, we have an isotonic saline solution that contains 9 grams of NaCl and 1,000 grams of water. Our first part of the question is to calculate the molarity of the solution. Let's define molarity, represented with a capital M, as the moles of solute divided by the liters of solution. Now let's think about what the solute is. Notice that we are taking 9 grams of salt and 1,000 grams of water, and the solute is the thing you're dissolving. This will be part A of the question, is finding the moles of the solute. Part B of the question will be to find how many liters of solution we have. When I say the word solution, I mean both the NaCl and the water together. Let's start with part A. So in part A, we're going to look at the solute, that's NaCl, and we're going to find the moles of NaCl. The information they give us about the NaCl is 9 grams of NaCl, and we'll start with that. Now we're going to multiply by a fraction to get out of grams and into moles. And recall that our conversion from moles to grams is going to involve the molar mass. The molar mass of sodium is 22.99, and the molar mass of chlorine is 35.45. If we add these together, we'll get 58.34. This number will be placed next to grams, and we'll place 1 mole on top, and then we'll do the operation 9 times 1 divided by 58.34. When we divide, we get an answer of 0.154 moles of NaCl. That is our solute. This will be the answer to part A. Now that we know the number of moles for part A, we will calculate the liters of solution for part B. Before we find the liters of solution, we'll first need to find the mass of the solution. So our solution consists of NaCl and water. Our NaCl is 9 grams, and our water is 1,000 grams. Add these together, and we get 1,009 grams of solution. Then we'll have to do a conversion. We cannot go straight from grams to liters, so instead we will go from grams to milliliters, and then from milliliters to liters, so that this is a 2-step conversion. Now we'll use density to go from grams to milliliters. After that, we will use our SI conversions to go from milliliters to liters. We'll begin with our 1,009 grams of solution. Start with 1,009 and multiply by a fraction. The grams we began with move to the bottom of that fraction. We'll use the density to go from grams to milliliters. Notice that our density here in the third line of the question gives us 1 gram for every milliliter. We'll say 1.00 next to the grams and simply 1 next to milliliters. Now we'll multiply by another fraction. We'll take the milliliters from the top, move them to the bottom, and remind ourselves that we are going to go to liters. According to the SI conversions, 1 liter is the same as 1,000 milliliters. So our operation is 1,009 times 1 and divide by 1,000. If you divide this in your calculator, you will get 1.009 liters. This is our answer to part B because this is the liters of solution. Now that we have both the answer to A and B, all we need to do is divide. So go to your calculator and divide the two numbers. We'll get an answer very close to the numerator. Our molarity will be 0.153. And when we represent the units, we represent them with a capital M. So our isotonic solution has a molarity of 0.153. The next part of this question now asks us to calculate the molality of the solution. Molality is represented with a lowercase m, and the definition of molality is the moles of solute on top divided by the kilograms of solvent. Let's remind ourselves that the solute is the thing we're dissolving, that's NaCl, and the kilograms of solvent is the thing we're dissolving it in, water. So we will have another part A where we calculate moles, and a part B where we calculate the kilograms of just the solvent. Note that the molality depends on the solvent, not on the total solution. So in that it is slightly different from molarity. Now from earlier, we found that this 9 grams of NaCl that we have is the same as 0.154 moles, and so we've actually already completed part A. We can reuse this answer from the previous question. So now all that's left is to do part B and find the kilograms of solvent. Our solvent is water, and we have 1,000 grams of it. We'll multiply by a fraction to take us out of grams and into kilograms. And according to the SI conversions, 1 kilogram is the same as 1,000 grams. If we divide 1,000 over 1,000, we will get 1 kilogram. And so our molarity is our answer from part A, which is 0.154 moles, divided by 1 kilogram. Dividing any number by 1 gives you the original number back, and so we'll have 0.154 molality of NaCl. Note that this is very close, but not exactly the same as our molarity. Our molarity was 0.153 of NaCl. So it's possible to have a molarity and a molality that are very close together, but it's unlikely they'll be exactly the same. Next, we'll move on to mass percent. The final part of the question asks us to calculate the mass percent of NaCl in the solution. And we'll define mass percent as the mass of the solute over the total mass. After that, to change to percent, we will multiply by 100. We'll remind ourselves that the solute was NaCl, and then for our total mass, we'll take the NaCl plus the water. So our NaCl, we can see, is 9 grams. That will go on top. On the bottom, we found previously that the total mass was 1,009 grams. 9 for the NaCl, 1,000 for the water. Then we multiply by 100. Go to the calculator and enter those operations. When you enter this into the calculator, you will get 0.892% mass of NaCl. And so we've covered 3 different concentration units: molarity, molality, and mass percent. Thank you for watching. We'll see you again soon.